Hello and welcome to Science Night Tales. I am glad you have found this quiet moment to look up. Tonight, we are going to trace a very old path, the one that leads from the ground beneath our feet to the stars above our heads. We often think of astronomy as a science of telescopes and equations, but it began much simpler than that. It began with eyes, patience, and the quiet realization that the lights in the sky were not random. We are going to follow the long lineage of people who watched the night, from the first stone circles to the backyard telescopes of today. We will see how our view of the universe grew larger, deeper, and more beautiful with every generation. You do not need to memorize constellations tonight. You can simply let the rhythm of the sky wash over you. The stars are steady, the night is calm, and you are safe to drift. If this perspective helps you feel connected to the vastness, you are welcome to like or subscribe. For now, let go of the day and let's watch the sky turn together. On a clear, dark evening, when the last light of day has faded completely, look up. The sky opens wide, vast, endless. Thousands upon thousands of tiny points of light scattered across it, some bright, some faint, arranged in familiar groupings that have stayed the same for as long as anyone can remember. A few wander slowly, drifting against the fixed background over the course of hours. The air feels cool against your skin. Distant sounds fade away. Only quiet remains, and the sky. We notice these things. Early people noticed them too. Long before anyone had telescopes or written records, they watched the same sky we watch tonight. Night after night, they saw the patterns repeat, the same bright points returning to the same places after days, after months. The moon changing shape in a steady cycle, or the sun rising and setting at shifting points along the horizon as seasons turned. They had no instruments, no charts, just eyes and patience. And yet they began to see regularity. The stars weren't random. They moved in ways that could be predicted if you watched long enough. Night after night, the same groupings appeared. The same wanderers traced their slow arcs. The moon waxed and waned in exactly 29.5 days. Seasons followed the same sequence year after year. In open fields, under that same sky, small groups started marking what they saw. They scratched lines on stones. They aligned wooden posts or standing rocks with a rising or setting of particular bright points. They counted days between identical events. Solstices, equinoxes, the return of certain stars at dawn. Over generations, they built simple charts, tallies of nights passed, records scratched into bone or clay. From those tallies came the first calendars, lunar months tracked by the moon's phases, solar years measured by the sun's yearly path along the horizon. Seasons tied to the reappearance of specific stars after their long absence. Practical knowledge, when to plant, when to harvest, when rivers would rise. But more than that, a growing sense that the sky held order. The patterns weren't accidents. They repeated, they could be counted, they could be anticipated. And once people realized that, the questions deepened. What lies behind this order? Why do these lights move the way they do? Is there a rule? A reason? Connecting everything we see up there. The sky that feels so distant, so unchanging. It suddenly feels like it might be trying to tell us something. And so we kept watching, night after night, across centuries, looking for the next clue. In those early open-air sites, people gathered again and again. They stood in the same fields, under the same turning wheel of stars. They noted when a particular bright point rose just before dawn, when another disappeared for weeks only to return. They aligned markers with the sun's farthest northern or southern rise, marking the longest and shortest days. These alignments weren't guesses. They were measured, repeated, passed down. Over time, the records grew more precise. Cycles were counted not just in days, but in years. The moon's path was tracked against the background stars. Eclipses were anticipated, their dates recorded so future generations could prepare. The sky became a kind of memory, etched into stone, wood, clay. A way to hold on to what had been seen so it wouldn't be lost. And with that memory came the first real organization. Observations weren't scattered anymore. They were collected, compared. Patterns that once seemed isolated started linking together. The wanderers, the planets, followed paths that crossed the same constellations year after year. The fixed stars formed unchanging backdrops. Everything moved, but everything moved in order. That order invited more questions. Why did some lights stay fixed while others wandered? Why did the moon return to the same place against the stars every month? Why did the sun's rising point shift slowly along the horizon, then reverse, then shift back? The sky was speaking in rhythms. We only had to listen longer. As those rhythms became clearer, people began to build tools to listen better. Simple lenses appeared, curved glass that brought distant lights closer. At first, they were small, handheld, used on quiet nights in private courtyards or early observatories. The view changed. Planets showed disks instead of points. Moons appeared beside them, small companions circling in their own paths. The Milky Way, once a faint band, resolved into countless individual lights, night after night. Observers pointed these early telescopes upward. They drew what they saw. They measured angles. They timed transits. The records grew thicker. Patterns once hidden became visible. The wanderers no longer drifted aimlessly. Their motions started to fit mathematical descriptions. Ellipses, predictable loops, rules that held true from one night to the next. And the more clearly we saw, the more questions grew. What force keeps these paths so precise? Why do the fixed stars seem fixed at all when everything else moves? What else is out there beyond the reach of these first lenses? The sky hadn't changed, but our view of it had, and that change pulled us further. The same sky, the same quiet nights, now carried deeper meaning. We had begun to map its rules, and once we started mapping, we couldn't stop. So the watching continued, with better tools, with shared records, with growing certainty that the order was real, and that we could uncover more of it. The patterns that early observers first noticed, the same ones we still see tonight, were just the beginning. They were the invitation. And humanity answered, step by step, night by night, century by century. Looking up, we still feel that same quiet pull. The sky is still there, still turning. In those earliest open-air sites, long before cities rose or writing took hold, people returned to the same places under the night sky. They chose clearings where the view was unbroken, flat ground, no hills blocking the horizon. Night after night they came back, the same groups, the same families, sometimes entire communities gathering in silence as darkness settled. They felt the night chill settle on their skin, the air growing cooler as the hours passed, sounds of insects and distant animals fading until only the quiet remained. Above them, the sky turned slowly, Stars rose in the east, crossed overhead, set in the west. Some rose at the same point on the horizon every evening. Others shifted a little each night. The moon appeared, thin crescent at first, then fuller, then waning again, always following the same sequence. They began to mark these returns, simple stones placed in lines, aligned with the rising of a particular bright star just before dawn. Wooden posts driven into the earth, pointing toward where the sun appeared on the longest day of the year. These were not random placements. They watched, waited, measured with their eyes and their steps. When the alignment matched again the next year, they added another stone, another marker. The pattern was recorded in the ground itself. Over generations, these sites grew, circles of stones, avenues of markers, all oriented towards specific points on the horizon where the sun or certain stars appeared at key times. Solstices, when the sun reached its farthest north or south. Equinoxes, when day and night balanced. The return of bright stars after weeks of absence. Each observation added to the next. The sky's movements were no longer just something that happened. They were something that could be tracked. From that tracking came the first calendars. The moon's cycle, 29.5 days from one new moon to the next, became the basic unit. 12 of those cycles, roughly a solar year, though not exact. People noticed the drift. The seasons didn't line up perfectly with lunar months, so they adjusted. Some groups added extra days, extra months, when the stars and the seasons no longer matched. Others watched the sun's path more closely, counting the days between solstices, dividing the year into quarters based on the equinoxes and solstices. These calendars served practical needs. When the river would rise and flood the fields, when the rains were likely to arrive, when certain plants would ripen, when herds would migrate. Navigation too. Travelers used the rising and setting of stars to hold a steady course across open land or sea. A bright star that rose due east at a certain time of year became a guidepost. Lose sight of it, and you knew you had veered off path. But the calendars did more than organize daily life. They gave the sky a voice that could be heard across time. A child could look at the same stones their grandfather had placed, see the same alignment, know that the sun would rise there again on the same day next year. The sky's order became shared knowledge, passed from one generation to the next, written not in words at first, but in alignments, in tallies, in memory. In the region later called Mesopotamia, observers climbed ziggurats, stepped towers that lifted them above the plain. From those heights they watched the same sky, but now with greater care. They recorded the positions of the brightest wanderers, the planets, against the fixed stars. Night after night they noted when Venus appeared as evening star, when Mars glowed red in the same constellation, when Jupiter moved slowly through the background. They scratched these positions on clay tablets, wedge-shaped marks pressed into soft surface, baked hard to last. Thousands of tablets, year after year, century after century. They built catalogues, lists of stars grouped into constellations, names for the patterns, names that carried stories but also positions. They tracked the 5 visible wanderers, their paths, on their periods of retrograde motion, when they appeared to slow, stop, move backward, then forward again. These motions were not chaos. They repeated. The tablets held the dates, the locations, the durations. Observers could predict when a planet would next stand still, when it would rise in the morning sky after long absence. Further south, along the Nile, groups aligned massive stone structures with the solstice sunrise. On the longest day, the sun rose exactly between two markers, light streaming down a corridor, illuminating the innermost chamber. They watched the star Sirius, the brightest in the sky, rise just before dawn after weeks below the horizon. That heliacal rising signaled the Nile's annual flood, the water that carried fertile silt to the fields. They counted the days from one rising to the next, 365, sometimes 366. The solar year took shape, tied directly to survival, to the river's rhythm, to the harvest. In the Far East, at royal courts, appointed astronomers kept watch from towers or open platforms. They recorded comets, sudden streaks across the sky, tails pointing away from the sun, appear without warning, then vanishing. They noted new stars, faint points that grew bright, then faded again. These events were entered into annals, year, month, day, position in the constellation. The records served the ruler, warnings of change, omens for the state, but also pure observation. Dates and places fixed so future watchers could compare. Across the ocean, in dense forests and open plateaus, other groups carved stone wheels, circles divided into segments, each segment marking a day in a larger cycle. They tracked Venus carefully, its 584-day period from one morning star appearance to the next, its cycles of visibility, invisibility, reappearance. They aligned buildings, stairways, doorways with Venus rising or setting. The planet's path became part of the calendar, a longer rhythm that guided planting, ceremonies, the counting of generations. In every case, the sky was not distant poetry, it was necessity, a tool for knowing when to sow, when to reap, when to travel, when to prepare. The stars were calendars, their motion carried meaning. The sky told time, told season, told direction. The patterns that once seemed scattered, irregular, now showed structure. The tension of not knowing, of waiting for rains that might not come, eased when the sky's signals were read correctly. Relief came with each accurate prediction, each aligned stone, each matching tablet. The sky, vast and distant, had begun to feel useful, not because it cared, but because we learned to read it, and once we read it, we wanted to read it better, with more precision, with something that could reach farther than the naked eye. So the watching continued. But now, eyes alone were no longer enough. From the open fields and stone alignments, from the clay tablets and heliacal risings, the sky had become something that could be counted. Patterns held, cycles matched the seasons, predictions worked. Knowledge passed from one watcher to the next, steady, useful, grounded in the needs of the day. But counting was not enough. The sky kept asking for more. Why did the wanderers loop backward? Why did their speeds change? Why did the fixed stars stay fixed while everything else moved? In the region of the Greeks, thinkers began to answer those questions not just by watching, but by reasoning. They took the records, the tallies, the repeated observations, and looked for underlying order. The sky was no longer only a calendar, it became a system, something that could be described, classified, explained. They first gave names to the patterns they saw, groups of stars, once just familiar shapes, received stories and labels: the hunter, the bull, the maiden, the scorpion, the bear that never sets. These constellations were not decoration, they were reference points. A traveler could say, "I am under the hunter's belt," and others knew exactly where in the sky that was. The fixed stars formed a background grid, unchanging, reliable. Wanderers moved against that grid, crossing from one constellation to the next in predictable order. The names made the sky mappable, easier to discuss, easier to remember. Observers noticed that the wanderers followed paths close to the same band across the sky, a wide circle called the ecliptic. The sun traveled that same path once a year. The moon stayed near it too. All the visible motion happened along or close to this single track. That was no accident. It suggested structure, a single plane, a common framework holding everything. One thinker proposed that the sky itself was made of spheres, nested layers turning around a central Earth. The fixed stars sat on the outermost sphere, rotating once each day from east to west, carrying everything with them. Inside that, separate spheres for each wanderer, turning at different speeds, tilted slightly, carrying the planet along its path. The daily spin explained why stars rose and set. The slower inner spheres explained why planets lagged behind the stars, why they drifted eastward night after night. The model was simple at first, elegant, built from observation. The spheres turned uniformly, perfect circles, because circles were complete, unchanging. Irregular motion, the backward loops, came from combining the daily rotation with the planet's own motion along its sphere. The eye saw retrograde, but the spheres themselves moved steadily forward. The sky had layers, each doing its part. I know chaos, only geometry working together. Later, another observer gathered centuries of records, Babylonian tablets, Greek measurements, his own nightly observations. He built a full system. Each planet moved on a small circle, an epicycle, whose center traveled along a larger circle around Earth. The epicycle explained the loops, the changes in brightness, the varying speed. By adjusting the size of the epicycle, the tilt, the rate of rotation, he could match almost every recorded position. The model predicted where Mars would be next month, where Venus would rise, when Jupiter would retrograde. The predictions were close, sometimes exact, for hundreds of years of data. He drew star charts, maps of the fixed background, with positions measured in degrees along the ecliptic. From a starting point at the vernal equinox, he catalogued over 1,000 stars, brightness, position, grouped into the named constellations. These charts were tools, reference works, passed to others who could add new observations, refine the coordinates. He also described instruments, armillary spheres, metal rings nested inside each other, representing the celestial equator, the ecliptic, the horizon, the meridian. An observer could align the device with the North Pole, set the rings to match the sky's tilt, then sight a star or planet through small holes or sights. Read its position directly from the graduated circles. The armillary sphere turned the sky into something measurable, something that could be held in a room, adjusted by hand, used to check theory against reality. These ideas were not abstract. They came from the same nights, the same chill air, the same patient watching. The records provided the raw data. The reasoning shaped it into order. The instruments tested whether the order held. The sky felt more structured now. Motion had names, classifications, predictions. The backward loops were no longer mysteries, they were consequences of geometry. The wanderers followed paths that could be calculated, not guessed. Quiet wonder grew with each step. The sky remained vast, distant, turning slowly overhead. But now it had rules that could be written down, tested, improved. The tension of unexplained motion eased. Relief came in the form of matching predictions, of seeing theory align with what the eye saw through the armillary rings. The same sky, the same quiet nights, now carried something new. Not just records, not just calendars, a framework, a geometry, a way to make sense of the motion. And once that framework existed, the desire sharpened to see more clearly, to measure more precisely, to reach beyond what the naked eye could catch. So the watching continued, but now with tools designed to bring the sky closer. Lenses, tubes, mounts, all built to test, to refine, to reveal what lay just beyond the limit of unaided vision. The ideas had taken shape, the constellations named, the paths described, the spheres and epicycles fitted to centuries of records. The sky had structure now, motion had rules, predictions matched what watchers saw night after night. But the tools were still simple. Eyes, markers. Armillary rings turned by hand. The distance remained, the details stayed hidden. So the work turned toward precision, toward measuring what could not yet be seen more clearly. They began with angles, small brass instruments, circles divided into degrees, sights aligned along edges. The Astrolabe came first, a flat disc, several rotating plates, pointers called alidades. An observer held it upright, aligned the base with the horizon, sighted a star through a small hole. Let the pointer fall. The star's altitude appeared on the graduated rim. Another plate, the rete, rotated to match the date, showed the star's position in the sky. The Astrolabe told time from the stars, found the sun's position by day, measured the height of a building or hill, even determined latitude when Polaris stood at its lowest. It was pocket-sized, portable, yet it reduced the sky to numbers, to degrees and minutes that could be written down, compared, passed on. They carried these instruments across deserts, up mountains, onto ships. On clear nights at sea, a navigator took sights of Polaris, measured its altitude above the horizon, read latitude directly from the scale. No land in view, no landmarks, only the sky. The Astrolabe gave position, allowed course corrections, turned the open ocean into something navigable. The same instrument that mapped the heavens by night helped find the way home by day. They built larger versions too. The quadrant, a quarter circle of wood or brass, mounted on a stand or wall. An observer stood beneath it, sighted a star along the edge, read the altitude from the arc. Larger quadrants, 6 feet across, fixed in observatories, gave finer divisions, minutes of arc instead of degrees. Readings repeated over years, errors averaged out, positions refined. The quadrant measured not just height, but the slow shift of stars over decades, the precession that moved the equinox point westward along the ecliptic, about 1 degree every 72 years. Sundials grew more precise. Simple shadow casters evolved into complex plates. Hour lines curved for latitude. Gnomons tilted to match the pole. Some showed not just local time, but time at other cities. The difference marked in degrees along the ecliptic. They tracked the sun's changing declination, its rising and setting points shifting day by day. The sundial became a quiet companion, always there, always measuring the same slow cycle. In observatories built like temples, domed rooms, open to the sky, groups worked with methodical calm. They set up mural quadrants, huge arcs fixed to walls, observers climbing ladders to sight through pinholes. They recorded transits, the moment a star crossed the meridian, timed with water clocks or sand, noted to the nearest minute. Night after night, season after season, the same stars crossed at the same sidereal time. But the sun's position drifted. The planets moved against the background. Each transit added a data point. Each measurement narrowed the uncertainty. In one great center, scholars collected tables. Ziggurats, thousands of entries. Planetary positions predicted for years ahead. Conjunctions, oppositions, retrogrades. The tables came from centuries of observations, Greek, Persian, Indian, all combined, recalculated, tested against new sightings. They used trigonometry, sine tables, to convert observed altitudes into ecliptic longitudes. The work was patient, repetitive, exact. A single error in one position could throw off predictions months later. So they checked, rechecked, averaged multiple observations, discarded outliers. The tables grew accurate, reliable enough for eclipses, for planetary conjunctions, for the timing of religious observances. These tables traveled. Merchants carried them across trade routes. Navigators used them at sea, cross-referencing star altitudes with predicted positions. The sky became a reference, a known map, even when the horizon was empty. The emotion was calm, deliberate, no rush, no sudden leaps. Only the steady accumulation of better angles, finer divisions, more consistent records. Each instrument, each table, brought the sky a fraction closer, not in magnification, but in understanding. The tension of uncertainty eased slowly, replaced by the quiet satisfaction of numbers that matched reality. They measured stellar distances indirectly, parallax too small to detect, but they knew the fixed stars were far, the planets nearer. They refined the obliquity of the ecliptic, the tilt of Earth's axis, down to minutes of arc. They corrected for atmospheric refraction, the bending of light near the horizon. So low stars appeared higher than they were. Every correction, every adjustment came from nights of careful sighting. Careful calculation, careful comparison. The observatories stood as places of patience, domes open to the sky, walls lined with instruments, tables of figures filling shelves. Observers worked in shifts, one group resting while another watched. The air inside stayed still. Lamps dimmed, voices low. Outside, the night chill pressed close. But inside, the sky was being measured, piece by piece. All this work, all these tools, built anticipation. The naked eye had limits. The astrolabe, the quadrant, the mural arc reached the edge of what unaided vision could do. They brought precision, but not closeness. The planets remained points. The moon showed no craters. The Milky Way stayed a band, not resolved into stars. The desire grew, to see what lay just beyond that limit. To bring the distant lights nearer, not just in calculation, but in appearance. And then, the first lenses appeared. Curved glass, simple tubes, the promise of magnification. The sky had been measured. Now, it was about to be seen. The same quiet nights, the same methodical care, now turned towards something new. A tool that would change everything, a leap from measurement to vision. The instruments had reached their limit. Astrolabes turned, quadrants measured, tables predicted with growing accuracy. The sky had been mapped, its motions classified, its cycles turned into numbers that matched reality night after night. But the distant lights remained points. The moon showed no detail. The planets stayed featureless disks at best. The view had sharpened in calculation, but not in sight. Then came the first tubes fitted with lenses. In a quiet room, away from the great observatories, someone pointed a simple device upward. Two pieces of curved glass, one convex, one concave, held in a short tube of wood or leather. The image trembled at first, edges blurred, colors fringed. But when the focus settled, the moon filled the field. Not the smooth circle everyone knew, but a world of texture. Craters, round and deep, some with central peaks, others overlapping older ones. Mountain ranges casting long shadows near the edge of light and dark. Plains that looked smooth from Earth, now broken by ridges, valleys, chains of small pits. The terminator, that line between day and night, showed jagged relief, shadows stretching kilometers across the surface. Or the same moon that had guided planting seasons, marked floods, lit night journeys, now wore a landscape. Rough, scarred, not perfect sphere, but a body shaped by time and impact. Observers drew what they saw. Night after night, the craters remained. The mountains stayed fixed. The shadows lengthened and shortened with the lunar day. The drawings spread, copied, discussed. People who had never held the tube saw the sketches, read the descriptions, understood that the moon was no longer a distant light. It was a place. The device improved quickly. Longer tubes, better lenses, steadier mounts. One observer, using a telescope of his own making, turned it toward Jupiter. The planet appeared as a small disk, banded faintly, and beside it, 4 tiny stars. Not fixed like the background, but aligned in a straight line, some above, some below, some on one side. Night after night he watched. The 4 moved, they changed places. Sometimes 3, sometimes 4, disappearing behind the planet, reappearing on the other side. They orbited Jupiter, clear, undeniable. Once the focus held steady. The discovery landed quietly at first, then spread. These were moons, bodies circling another world. Not everything orbited Earth. Jupiter had its own companions, 4 at least, moving in paths that could be timed, predicted, just like the moon circled us. The same lens turned to Venus, bright, steady, but through magnification, phases appeared. Crescent, half, gibbous, full, then back again, exactly like the moon. Venus grew larger when crescent, smaller when full. It orbited the sun, not Earth. The geometry was clear. If Venus circled Earth, it would always show the same phase, but it didn't. It showed the full range. The center of motion could not be here. The sky shifted in that moment. Earth was no longer the hub. The planets moved around the sun. The moon moved around Earth, but the others followed a larger path. The order was still there, the cycles still predictable, but the arrangement had changed. The universe grew larger, more layered, and we grew smaller in it. Another thinker, working from these observations, took the measurements further. He gathered positions, times, distances, brightness changes. He tested shapes, not circles, but ellipses. The planets moved on elliptical paths, the sun at one focus. Speed varied, faster near the Sun, slower farther away. The area swept by the line from planet to Sun stayed constant over time. The square of the orbital period scaled with the cube of the average distance. These were laws, not guesses, not models fitted after the fact. They described motion everywhere, from Mercury close to the Sun to Saturn far out. They predicted where each planet would be, not just for weeks, but for years, decades. The backward loops, the changes in brightness, the varying speeds, all followed naturally from ellipses, from one simple rule of gravity pulling toward the Sun. The telescope had done more than show detail. It had reframed everything. The Moon was a world. Jupiter had moons. Venus showed phases that placed it around the Sun. Kepler's laws turned wandering lights into orbiting bodies, governed by the same rules, the same geometry across the entire system. Gentle astonishment settled in. The sky remained beautiful, vast, turning slowly overhead. But now it was a system, not a mystery. Motion had become law. The cosmos had order, deep, consistent, beautiful in its simplicity. The same quiet nights, the same patient watching, now carried a new weight. We had seen beyond the points of light. We had measured paths that spanned invisible distances. We had placed ourselves not at the center, but as observers, small, yet able to understand. The astonishment was quiet, humble. No one shouted. No one claimed victory over the sky. Instead, the wonder deepened. The universe had grown, and so had the questions. What else lay out there? What are the moons? What are the worlds? What rules governed bodies too faint, too distant for these first lenses? The telescope had opened the door. The sky invited us to step through. And we kept building better instruments, kept watching, kept asking. The revolution had begun, not with noise, but with clarity, with detail, with laws that held true under the same turning stars we still see tonight. And so, the night continued, calm and patient. The telescope had changed everything. Planets became worlds with features, moons, phases, elliptical paths governed by clear laws. The solar system took on order, a sun-centered arrangement, motion explained by geometry and gravity. The sky no longer felt like a ceiling of lights. It felt like a place, a system we could measure, predict, understand. But the fixed stars, the background, remained distant points. They did not wander. They did not show disks or companions. They stayed fixed, unchanging, except for the slow daily rotation. So the attention turned outward, beyond the planets, toward the farthest lights. One observer, working alone at first, then with small groups, began to count them systematically. He built larger telescopes, longer tubes, bigger mirrors, to gather more light, to see fainter objects. Night after night, he swept the sky, section by section, noting every star that came into view. He catalogued them: brightness, position, clustering. Some areas showed dense groupings, others sparse. The Milky Way, that faint band across the sky, resolved under his lens into countless individual points. Stars upon stars, so many that the eye could not separate them all. He found that the stars were not evenly spread. They formed layers, concentrations, streams. The Milky Way was not a cloud, but a structure, a disk seen from within, with the sun somewhere near the plane, not at the center. The fixed stars were not fixed in a single shell. They existed at different distances, some nearer, some much farther. Their apparent brightness a clue to how close they stood. He also found objects that did not look like stars, small patches of light, fuzzy, extended, without sharp points. Some appeared round, others irregular. He called them nebulae, clouds, because they resembled faint mist under magnification. Hundreds of them, scattered across the sky, some bright, some barely visible. At first, they seemed like distant gas, perhaps unresolved star clusters, perhaps something else. But as the telescopes grew larger, some nebulae showed structure, spiral arms, central brightenings, hints of rotation. They were not local clouds. They were separate systems, vast, far beyond the stars we could count individually. The scale began to shift. The solar system, once the entire known cosmos, became small. The fixed stars, once the outer boundary, now filled a disk, a galaxy, with the sun one point among billions. And beyond that disk, these nebulae, each one potentially another collection of stars, another system like our own. The universe had layers, planets, stars, the Milky Way. Then these distant clouds, each layer farther, each layer larger. The distances were hard to grasp. Light from the nearest stars took years to reach us, from others, centuries, from the nebulae, perhaps millions of years. The eye saw them in the present moment, but the light had left long before, carrying information from a past we could not reach. The sky was not only wide, it was deep. Time entered the view. The farther we looked, the farther back we saw. The observers measured positions more precisely, compared brightness, searched for parallax, the tiny shift of nearby stars against the background as Earth moved around the sun. The parallax was small, barely detectable, but it gave the first real distances. A few stars stood close, others much farther. The galaxy stretched tens of thousands of light years across, the sun off-center near one spiral arm. The nebulae, when measured later, lay far outside, separate, each one a galaxy in its own right. The emotional shift was quiet, reflective, no sudden overturning. Just the slow realization that what we had called the universe, the collection of planets and stars we could see, was only a tiny part. We stood on one planet, orbiting one star, in one galaxy, among countless others. The insignificance was calm, not crushing. It was simply true. The sky had grown larger than imagination, and we had grown smaller within it. Yet the wonder remained, because we could see it, because we could measure it, because each improvement in the telescope, each longer night of sweeping, each new catalogue, added another layer, another depth. The Milky Way, once a faint streak, now a vast disk of stars. The nebulae, once misty patches, now distant systems. The universe, once bounded by the fixed stars, now extended into depths we could only glimpse. And still the sky turned overhead, same as always, the same chill air, the same quiet, but now carrying the weight of immensity. The same stars we had watched since the first alignments, the same constellations, now part of something far greater. The astonishment settled gently. We were not at the center. We were not even close to the edge. We were observers, small, brief, yet able to extend our sight, to count, to understand, across distances that defied everyday thought. The telescope had not just shown more detail, it had shown more everything, more space, more time, more scale. And with that scale came a new kind of humility. The cosmos did not revolve around us. It simply was, vast, layered, ongoing. But we could look, we could measure, we could add our small piece to the map. So the watching continued, with larger mirrors, longer exposures, better eyes. The sky kept revealing layers, and we kept going deeper. The questions grew with the view. What lay beyond these distant systems? How many more? What held them all together? The universe had become bigger, and the wonder deeper, calm, reflective, steady. And still the night sky waited, patient, for the next lens, the next measurement, the next quiet realization. The layers kept unfolding. The Milky Way had resolved into a vast disk of stars, billions upon billions. The Sun, one ordinary point far from the center. Nebulae, once thought to be local clouds, began to show themselves as separate systems. Spiral arms, central brightenings, vast collections of stars in their own right. Distances stretched into hundreds of thousands, then millions of light years. The universe was no longer the solar system plus a backdrop of stars. It was galaxies, island universes, scattered through depths we could only begin to measure. One observer, working at a large reflector on a mountain, turned the telescope toward faint patches that earlier instruments had barely glimpsed. He searched for ways to find true distances, beyond the parallax that worked only for the nearest stars. He focused on a particular type of star, variable stars that brightened and dimmed in regular cycles. Cephids, named for the prototype, pulsed with periods from a few days to weeks. The longer the period, the brighter the star at its peak. This relationship, period luminosity, was the key. He measured the cycles carefully, night after night, recording brightness changes. Then he applied the law. If a Cephid had a certain period, its true brightness was known. Compare that to how faint it appeared from Earth, and the distance followed directly. No guesswork. Just light, dimming with the square of the distance, and a reliable standard candle. He found Cephids in the Andromeda Nebula, one of the brighter fuzzy patches. The periods told him the distance, hundreds of thousands of light years, far beyond the Milky Way's edge. Andromeda was not a cloud within our galaxy. It was another galaxy, similar in size, similar in structure, separate, distant. The universe had doubled in scale, at least. He pushed further. More Cephids, more nebulae. Each one measured turned out to be millions of light years away. The spiral arms, the central bulges, the scattered star clusters, all belonged to independent systems. The sky filled with them. Thousands. Tens of thousands, each one a galaxy, each one containing billions of stars, each one a world unto itself. The reframing settled slowly. The Milky Way, once thought to contain everything, became one galaxy among many. The solar system shrank to a single star system in one galaxy among countless others. Space was not merely wide, it was populated, layered, immense in ways that defied ordinary scale. Then came the next step. He measured the spectra of these distant galaxies. The light split into colors. Lines shifted toward the red end. The farther the galaxy, the greater the shift. The lines moved, not randomly, but systematically. More distant objects showed larger red shifts. The interpretation followed. The light was stretched, the wavelengths lengthened. Other because the galaxies were moving away, not just a few, but all of them, in every direction. The farther they were, the faster they receded. The universe was expanding, not exploding outward from a point, but space itself stretching, carrying the galaxies along. Closer ones moved slowly, distant ones faster, the relation linear, predictable. The rate became known, kilometers per second per megaparsec, a number that measured how quickly the fabric of space grew. The view deepened. Later telescopes, larger mirrors, longer exposures, pointed at apparently empty patches of sky. Tiny fields, no brighter than a pinpoint. Hours, days, weeks of exposure. The images returned filled with light. Thousands of galaxies, faint, distant, packed into what had seemed blank space. Spirals, ellipticals, irregular shapes. Some so far that their light had traveled billions of years to reach us. Each tiny smudge, another collection of stars, planets perhaps. Entire histories unfolding in light that left before humans existed. The scale multiplied again. Billions of galaxies, each with billions of stars, stretching across billions of light years. The observable universe, the part we could see, spanned tens of billions of light years. The light from the farthest objects starting its journey when the universe was young, when stars and galaxies were just forming. The emotion was soft, existential, wonder without despair. We were small, one species on one planet orbiting one star in one galaxy among hundreds of billions. The numbers pressed gently, not overwhelming, just true. Or the universe did not need us to exist. It had existed for billions of years before us, would continue long after. Yet here we were, looking, measuring redshifts, counting galaxies in empty patches, extending our sight across time and distance. The humility felt calm, not diminishing. Because we could see it, because we could understand pieces of it, because each generation added another layer, another depth, another number that fit. The same night sky, the same quiet turning, now carried this immense context. The stars we first aligned with stones, the constellations we named, the wanderers we tracked, all part of one small corner, one quiet galaxy, floating in an expanding sea of others. And still the wonder held. Because the universe, in its vastness, allowed us to look, to measure, to know. The reframing was complete, from points of light, to planets, to stars, to galaxies, to an expanding cosmos. From center stage to observers on the edge, yet connected through light, through curiosity, through the simple act of looking up. The sky remained patient, the same chill air, the same slow rotation. But now it whispered of depths beyond depths, of time beyond time, of scale beyond grasp. And we kept listening, with larger telescopes, longer exposures, deeper questions. The participation was quiet, ordinary, human. Anyone with a dark sky, with patience, with a small telescope, could glimpse the same layers, the same galaxies, faint in backyard instruments, but real, distant, part of the same expanding whole. The universe had grown, and so had we, not in size, but in reach, in understanding, in the calm, steady, shared act of looking farther. And the night sky waited, as always, for the next question, the next measurement, the next moment of quiet realization. The great telescopes had shown us depths we could scarcely imagine, galaxies by the billions, expansion stretching space itself, light from billions of years ago arriving in the present moment. The universe had multiplied in scale, layer upon layer, until the mind could only accept it quietly, humbly. The professional observatories, mountain peaks, domes opening to clear skies, teams working through long nights had carried us there. But the sky had never belonged only to them. It belonged to anyone who looked up, in backyards, on rooftops. In suburban fields away from city lights, people set up their own telescopes, small refractors, 6-inch reflectors, 8-inch Schmidt-Cassegrains, affordable, portable, carried out in cases or on simple tripods. The setup was quiet, a dark spot chosen, away from street lamps, away from windows. The tube aligned roughly with Polaris, finder scope used to center a bright star. Slow motion controls adjusted until the image steadied. Then, the eyepiece swapped, magnification increased, focus fine-tuned. The same stars that had guided ancient alignments now appeared larger, sharper, showing color, faint companions, clusters that resolved into individual points. The view felt intimate. No vast array, no mountain dome, just one person, one instrument, one patch of sky, or the chill air pressed close, breath visible, fingers cold on the focuser. But the telescope brought the sky nearer, made it personal again. Some turned their attention to comets. Amateur hunters scanned the dawn or dusk sky, near the sun, where faint visitors appeared. They learned the patterns, the way a new comet brightened slowly, developed a tail, moved night by night against the stars. When one appeared, they measured its position, estimated magnitude, sent reports to central bureaus. The comet might be new, discovered by someone in a backyard, its orbit calculated, its return predicted decades later. The contribution was small, a single position, a brightness estimate. But it added to the global picture, helped refine trajectories, warned when a comet might brighten unexpectedly. Others watched variable stars, stars that changed brightness. Some regularly, some irregularly. They chose targets from lists: Delta Cephei, Mira, Algol, R. Leonis. Night after night, they compared the star's brightness to nearby constant stars, estimated magnitude to the nearest tenth, recorded the date and time. The data went to organizations, plotted as light curves, period determined, amplitude measured. A single observer, over months, might contribute hundreds of points, enough to refine the period of a long-period variable, to detect changes in amplitude, to help classify new variables. The work was patient, no sudden discoveries, just repeated observations, careful estimates, consistent records. The sky rewarded the steady hand, the dark sight, the willingness to return night after night. A light curve emerged, rise, peak, fade, repeat, sometimes with small irregularities that told of pulsation, mass loss, companion stars. The amateur's curve joined thousands of others, built into databases, used by professionals to study stellar evolution, distance calibration, galactic structure. These were not isolated efforts. Groups formed, clubs, online forums, annual meetings under dark skies. Observers shared tips, lent equipment, compared notes. One person's faint nova alert reached another who confirmed it, then another who measured its spectrum. The culture grew quietly, inclusive, built on trust in careful work, no matter the size of the telescope. The same stars, the same constellations. That had once marked planting seasons. now served new purposes. A backyard observer could measure the period of a Cepheid in a nearby galaxy, contribute to distance ladders, help calibrate the expansion rate. Another could track a transiting exoplanet, the tiny dip in a star's light as a planet passed in front, timing the event, determining the planet's size and orbit. These were not professional projects. They were done with 8-inch telescopes, CCD cameras, laptop computers, software freely available. Yet the data entered global databases, analyzed alongside observations from space telescopes, used to confirm new worlds, to refine parameters, to add to the growing catalogue of planets beyond our solar system. The intimacy returned. The sky felt close again, not because it had shrunk, but because we had reached back toward it with our own hands. The great reframings, galaxies, expansion, deep fields had placed us in vast context, but the small telescopes brought us home. One person, one night, one careful measurement still mattered, still added to the whole. The emotion was warm, familiar, a sense of inclusion. No one needed a mountain observatory, a dark backyard, a steady mount. Patience and the willingness to look again were enough. The universe had grown immense, but it had also made room for anyone who wanted to participate. The same night chill, the same slow tourney overhead now carried this quiet connection. The stars that ancient watchers had aligned with stones, that Greek thinkers had fitted into spheres, that modern professionals had measured in redshifts, were the same stars visible from a suburban driveway. We were part of the story, not at the center, not even close, but included through simple tools, repeated effort, shared data. The wonder felt personal again, soft, steady, welcoming. And so the watching continued, not only in domes on distant peaks, but in backyards, on rooftops, under the same sky, by people who simply looked up and decided to measure what they saw. The sky waited, patient, open, for the next observer, the next night, the next small contribution that would add another piece to the map. And somewhere, in a quiet field, under familiar constellations, someone was already setting up a telescope, focusing carefully, beginning the next measurement. The story had not ended. It had only become larger and at the same time more intimate. The continuity had never broken. The same night, sky that ancient watchers aligned with stones, that Greek thinkers fitted into spheres, that early telescope users revealed as a system of worlds, that large observatories expanded into galaxies and expansion, remained the same sky. The same stars rose and set, the same constellations wheeled overhead. The same quiet chill settled as darkness deepened. What changed was not the sky. What changed was us, our tools, our reach, our willingness to keep looking. Now, in the present, that same sky yields new worlds, not through mountain domes alone, but through networks, through shared effort, through ordinary people contributing from their own backyards or computers. The method is simple in principle, subtle in practice. A star shines steadily, then dims, then brightens again. The dip is tiny, a fraction of a percent, lasting hours, but it repeats regularly, predictably. The cause, a planet passing in front, blocking a small portion of the star's light. Transit. The depth of the dip tells the planet's size relative to the star. The timing between dips tells the orbital period. Multiple transits, from the same star, confirm the signal. Rule out false positives. Allow the orbit to be mapped. Professional telescopes in space pointed at hundreds of thousands of stars, found thousands of these signals, but confirming them, refining them, exploring the edges, required more eyes, more measurements, more patience. Citizen science projects opened the door. Anyone with internet access could log in, view light curves, folded data, graphs showing brightness over time. The task was straightforward. Look at the curve, identify the dip, its shape, its depth, its repetition. Classify it, transit, variable star, binary eclipse, artifact. Or flag it as uncertain for review. Thousands of people, in living rooms, on laptops, during lunch breaks, after children slept, did exactly that. Each classification, each flag added to the pool helped algorithms learn, helped professionals prioritize follow-up. The contributions were small, one curve at a time, one decision at a time, but they accumulated. Light curves from backyard telescopes, photometry from small observatories joined the space-based data. Amateurs measured transit timings, refined ephemerides, caught changes in period that hinted at additional planets, or moons, or rings. A single backyard observer tracking a known system might notice an extra dip, a subtle deviation, report it, and help confirm a multi-planet system or a new world. The catalogues grew. Thousands of confirmed planets, sizes from smaller than Earth to larger than Jupiter, orbits from days to years around stars of every type. Some rocky, some gaseous, some in the habitable zone where liquid water could exist. The patterns emerged slowly from the collective watching. Many stars had multiple planets, packed close, resonant orbits, systems flatter than ours. Some planets circled dim red dwarfs, close enough for tidal locking. One side always day, one always night. Others orbited sun-like stars, farther out, colder, but stable. The sky had not changed. The same stars we first named, the same constellations that guided ancient travelers, now hosted these worlds. A backyard telescope could point to a faint star, magnitude 8 or 9, and watch its light dip, night after night, revealing a planet crossing its face. A world perhaps thousands of light years away, yet seen, measured, known. The emotion was quiet hope, not loud excitement, not triumphant claim. Just the gentle realization that discovery was not finished, not reserved for distant peaks or spaceborne instruments. It lived here, in the same sky, under the same stars, through the same patient effort that began with stones aligned to solstice sunrises. Anyone could participate. A small telescope, a dark site, a camera, software, and time. Or simply a computer classifying light curves, one at a time. The contribution mattered. It added data points, refined statistics, helped find the rare, the unusual, the potentially habitable. The arc felt complete, yet open. From the first watchers who marked star returns to survive seasons, to the thinkers who named patterns and fitted spheres, to the lens makers who brought detail, to the catalogers who mapped galaxies, to the classifiers who found worlds in dips of light. The thread remained unbroken. Curiosity, observation, measurement, sharing. The same human impulse across eras, across tools, across scales. The sky stayed vast, indifferent, immense, but now it included us, not as center, not as endpoint, but as participants. Small, brief, yet persistent. We could look, measure, contribute, understand a little more each night. And the wonder stayed gentle, because the universe, in its depth, had left room for us. For backyard telescopes, for laptop classifications, for quiet nights when someone, somewhere, saw a dip, recorded it, and added one more world to the map. The same constellations turned overhead, the same chill settled, the same quiet held. But now, the sky carried new names, new places, new possibilities, worlds we could not touch, yet could know. Through light, through patience, through shared watching. And somewhere tonight, under that same sky, someone is setting up a telescope, or opening a light curve, or simply looking up, asking the next question. The story continues, quietly, patiently, with the same gentle wonder that began it all. The sky waits, as it always has, for the next observer, the next measurement, the next small step toward understanding. And we, still watching, still contributing, still part of it. The night has deepened now. The same sky stretches above, vast, quiet, turning slowly as it has for every watcher before us. The air carries that familiar chill. The distant sounds have faded, only the soft rhythm of breath remains, and the faint glow of stars filtering through whatever quiet place you find yourself tonight. Look up. Those same points of light, the same groupings, the same slow wanderers tracing their paths are still there. They have not changed. The constellations we named thousands of years ago, the patterns ancient eyes first marked with stones, still hold their places. The moon still cycles through its phases, 29.5 days from thin crescent to full and back again. The planets still drift against the fixed background, following the same elliptical roads Kepler described, governed by the same gravity that keeps everything in motion. What has changed is us. From the first people who stood in open fields, felt the night settle, and scratched tallies on bone, to the thinkers who drew circles and spheres, to the lens makers who brought craters into view, to the catalogers who counted galaxies, to the quiet observers tonight, measuring a dip in light, classifying a curve, or simply watching because the sky is beautiful. The thread runs unbroken. We are not separate from them. We belong to the same line. The curiosity that lifted eyes to the solstice sunrise, that held an astrolabe steady against the horizon, that adjusted a focuser until Jupiter's moons came clear, that clicked through thousands of light curves on a screen, lives in the same impulse tonight, the same gentle pull, the same quiet question, the same willingness to return, night after night, to look again. The sky has never asked for anything. It simply is. Patient, unchanging. A witness to every generation that paused, looked upward, and felt the vastness settle around them. It watched the first alignments rise from the Earth, the first telescopes focus, the first redshifts measured, the first citizen classifications added to the map. It watches still, indifferent, immense, yet somehow present, as though it has always known we would keep coming back. And we do. Tonight, perhaps in a backyard, perhaps from a window, perhaps just stepping outside for a moment. We stand in that same lineage. The tools are different, the questions deeper, the scale larger, but the act remains the same. Looking, seeing, wondering, measuring when we can, contributing when we're able, belonging simply because we show up, because we care enough to notice. There is no center here, no privileged place. We are small, brief, one species on one world, orbiting one star, in one quiet corner of one galaxy, among billions. Yet that smallness does not diminish. It connects, because the sky makes room for us, for our questions, for our careful records, for our shared effort across time, across continents, across the simple divide of night and day. The wonder settles gently now, not loud, not urgent, just warm, familiar, like coming home after a long journey. The stars above, the same ones that lit ancient fields, that guided ships, that revealed galaxies, that showed us worlds in tiny dips of light, are still shining. They will shine tomorrow and the night after, long after our own watching ends. And someone else, somewhere, will look up, feel the same pull, add their own small piece, continue the quiet conversation we have been having since the beginning. So rest now. Let the sky hold its own rhythm. Let the turning continue without hurry. The patterns are still there, waiting, patient, unchanged. And so are we, part of them, part of this long, gentle, unbroken line of looking upward. The night is deep, the air is cool, the stars keep their places, and somewhere in that vast turning, we belong. Sleep comes easy under such a sky. It always has, it always will. The same constellations that once marked planting seasons, that guided traveler across deserts and seas, that revealed moons and phases and laws, that opened galaxies and expansion and distant worlds, are still turning above you now. No rush, no need to hurry. The sky does not demand answers tonight. It only offers presence, the quiet certainty that everything continues, that the questions we carry are not new, that they have been carried before and will be carried again. Your breathing slows, the chill on your skin fades into the background. The faint glow of stars softens at the edges of vision. The turning feels slower, more gentle. A lullaby written in light and shadow and time. This is the same sky. The same one that watched the first stone alignments rise, that saw lenses focus for the first time, that held redshifts and deep fields and light curves, that still holds every measurement, every classification, every quiet contribution made tonight by someone somewhere. You are part of it, not because you must be, but because you are here, because you looked, because the curiosity stirred, even if only for a moment. The lineage is long. It stretches back through centuries, through generations, through countless nights just like this one. And it stretches forward into nights you will not see, carried by others who will feel the same pull, who will set up their own small telescopes, who will open the same light curves, who will simply stand outside and look up. The sky does not change for us. Yet it does not hurry, it does not wait. It simply is. And in its being, it includes us. Always has, always will. So let go now. Let the questions drift. Let the wonder settle into something softer, something warmer, something that does not need words. The stars are still there. The turning continues. The quiet holds. And somewhere, deep in that calm, you are exactly where you belong. Sleep. The sky will still be here when you wake. It always is.